So let's take a look at slide 15. So slide 15, we end up going back and kind of having to refer back to a couple of the other slides that we've already seen. Let's first go and take care of our quadrants first. We'll then take care of the reference angles, and then we will evaluate each one. The first thing would be, let's take a look at the quadrants themselves. In order to take a look at the quadrants, we are going to take a look at what is going on with the degree or the radians, depending on what we are looking at. So in this case, because we are looking at a negative 45 degree angle, we know that this would be quadrant 4. Now, we're going to run through each one of these scenarios first, and then at that point, we would be able to go ahead and go into the next question. Let's take a look at whether it is positive or negative. Now, in this case, when they are referring to the positive and negative state of this problem, they are referring to the sign. Now, if you were to go back to slide 11, this is where we kind of go over all students take calculus. And that is going to tell you which one of our trig functions is going to be positive and where. So in quadrant 1, all of them are going to be positive. In quadrant 2, we have only the sine and cosine. Sine and cosecant. That would be positive. We have tangent and cotangent, and we have cosine and secant, which would be positive. Now, in this case, since we are looking at a sine, notice sine would only be positive in the second quadrant. Because we are in the fourth quadrant, this would mean that this would be negative. Our next step would be our reference angle. Well, if we're looking at negative 45 degrees, that means that we would be extremely close to the 0 mark on the x-axis, which means that our reference angle would be 45 degrees. The last step would be to evaluate. Now, in order to evaluate, you truly have to work and understand and create your unit circle. It's understanding that anytime that we have a point that we are in reference, it would go cosine, then sine for our points. Now, in the case of negative 45 degrees, what would end up happening is that we would take a look at what specific point it would have. In this case, negative 45 degrees would be 7 pi over 4, or 315 degrees, which would be the same as us looking at pi over 2, square root of 2 over 2, comma, negative square root of 2 over 2. Now remember, here we're looking at specifically just the sign of this problem. In this case, it would be the back end. So our answer here would be a negative square root of 2 over 2. And that's how you'd find the answer for each one of these different problems. Now, let's continue working through a couple of these different problems just to be sure that everybody has a pretty good understanding of how to find their answers. First thing would be, take a look at your 120 degrees. Your 120 degrees would actually fall within quadrant 2. Now we know that in quadrant 2, the only thing that is positive would be your sine or cosecant. In this case, this would be negative. Our reference angle for this would be 60 degrees to get up to 180. And we're going to take a look at our 120 degrees. And based off of 120 degrees, that point would be negative 1/2 and pi over 3. I'm sorry, square root of 3 over 2. Now remember, we're looking at cosine and 120. Since we're looking at cosine and 120, cosine would be our x, and in that case, our answer here would be a negative 1/2. Now remember, this is coming mainly off of your unit circle and knowing exactly where that point ends up being. We're going to go ahead to the next problem. We have the tangent of 5 pi over 6. Let's first start off with what quadrant? So 5 pi over 6 would be in quadrant 2. And we know that because 6 pi over 6 would end up giving us 180. So since we are falling just short, it would be in quadrant 2. We go ahead, take a look at all students take calculus, and the only thing that is positive within quadrant 2 is our sign. So this makes this negative. We take a look at our reference angle. Now, when we're looking at 5 pi over 6, in order to get up to that 180 or that 6 pi over 6, we would need another pi over 6. At that point, we go ahead, we take a look at what our point would be in the case for tangent. Now, our points, keep in mind, are always in reference to specific cosine and sine. So even though our point is cosine and sine, we have to remember that tangent is equal to sine divided by cosine. So first thing we need to do is find the exact point for 5 pi over 6. 5 pi over 6 would give us negative square root of 3 over 2, comma, 1/2. Now knowing this, we're going to go ahead and we're going to divide our sine by our cosine. So we're going to say 1/2 divided by negative square root of 3 over 2, which is the same thing as 1/2 times negative 2 over the square root of 3. We can simplify this out. 2 and 2 simplify to 1 and 1. Our final answer here would be a negative 1 over the square root of 3. We do want to rationalize it and make sure that that square root of 3 is eliminated from the denominator. So this would turn into a negative square root of 3 over 3. This right here would be our answer. Negative square root of 3 over 3. Now, as you start running into some of these other problems, as far as secant, tangent, cosecant, keep in mind, secant is the inverse of our cosine, and our cosecant is the inverse of sine. So use that understanding of our inverse functions to be able to flip and work your way through these problems. Now, I cannot stress it enough, you will need to know your unit circle. Highly suggest you become very familiar with it and be able to go ahead and place everything that needs to be placed in the correct areas. That would be going accordance to your degrees, your radians, and your points. Let's take a look at slide 16. Now, for this slide, what we're doing is we are taking a look at our original trig functions. So we have theta is equal to 2 pi over 3. We have theta is equal to negative pi over 2. We have theta is equal to 7 pi over 4, sine of 315, and the cosecant, or the cosine of negative 135. So, first thing we're going to do is we're going to go ahead and understand exactly what is being given with each one of these. So let's start off with ultimately our first part, which is theta is equal to 2 pi over 3. So for this problem, first thing that we're going to do is we're going to understand that 2 pi over 3. First, we're going to tell what quadrant we are in. We are also going to take a look at our reference angle. And you also want to state whether that quadrant is going to be positive or negative. So let's start off with 2 pi over 3. First thing would be, what quadrant would 2 pi over 3 be? And that would be quadrant 2. Now, since we are going to go ahead, remember, all students take calculus. We know that in quadrant 2, our sign is positive. Now our reference angle would be pi over 3. Once we have that, we can go ahead and take a look at what the sine would be of our exact point. Remember, every single time that we're looking at the point, it is always cosine, comma sine. So in the case for 2 pi over 3, that would be square root of 3 over 2. You're going to go ahead and we're going to do the exact same thing for our next problem. And we're doing theta is equal to negative pi over 2. In this case, this would actually be a quadrantal angle. And we know that because negative pi over 2 would actually be a negative 90 degrees because it falls on the 90, 180, 270, 0, or 360. It is quadrantal. We're going to go ahead. Notice in this case, it's not going to have a positive. It's not going to have a negative. The only thing that we can really check is to see where is it that it falls. And in this case, it is 0, negative 1. Remember, this is sine cosine. The sine of this would be negative 1. Let's go on to the sine of 315 degrees. Main reason for that is just that since we've done a couple of radicals already, you'll be able to see exactly how it's done with it being given in degrees. First thing that we're going to do is we're going to take a look at what quadrant is 315 degrees in. And we would say this is the fourth quadrant. Would this be positive or would this be negative? Well, for sine, this would be negative. we're going to go ahead and take a look at the reference angle. The reference angle would be 45 degrees. Now from here, we're going to go ahead and we're going to take a look at the sine of 315. Sine of 315 would be a negative square root of 2 over 2. And last one that we're going to take a look at is the cosine of negative 135. First thing would be our negative 135. That's going to leave us with quadrant 3. Notice quadrant 3 is only tangent. That would be positive, which means this is negative. We're going to take a look at our reference angle. In this case, our reference angle would be 45 degrees. When we take a look at negative 135, that would leave you with negative square root of 2 over 2. Now you would repeat this process for each and every single one of your different trig functions. You would do it for sine, you would do it for cosine. Keep in mind, when we're working tangent, tangent is equal to sine over cosine. And when you are finding that final answer, you will have to divide sine by your cosine. Also keep in mind, when you divide a fraction by a fraction, you will have to keep, change, flip. For 1 over cosecant, remember this is the same as 1 over sine. Secant would be 1 over cosine. And our cotangent would be cosine over sine. The same can be repeated throughout the entire slide. So let's go ahead and take a look at our last problem, which we'll do together, which is going to be the theta is equal to 7 pi over 4. So 7 pi over 4 would actually be quadrant 4. Now with 7 pi over 4, we're going to take a look to see whether it is positive or negative. In this case, since we are looking at the sine of theta would be only positive in quadrant 2. It would not be positive in quadrant 4. Now, from there, we're going to go ahead and mark that down as a negative angle. We're going to take a look at our reference angle, which is going to be 1 pi over 4. And we're going to go ahead and take a look at the sine of that point, which would be a negative square root of 2 over 2. Once again, remember, it is always our cosine that describes the x value of a point. The sine is the y value of the point. Hopefully this helps to give you a better understanding of the second half of our 9.4 section. I can't stress it enough. You must know your unit circle. Be familiar with not only the degrees, know the radians, know your points, be able to understand your reference angles, At that point, keep in mind they will always be positive for your reference angles, and be familiar with all of your different trig functions as far as what those equations equal out to. Hopefully this helps.